Welcome to the Explainer. In algebra, some of the biggest, messiest problems can actually be untangled with one single powerful tool. Today, we're unlocking that tool. It's called factorization. It's all about taking something that looks super complex and breaking it down into simple, elegant pieces. And that's the key to solving equations and simplifying some really huge problems. So, let's get right into it.
Have you ever looked at an expression like this one and your brain just kind of shuts down? It looks like a total jumble of letters and numbers, right? But what if I told you there's actually a method to the madness, a systematic way to make sense of it all?
Well, that system is factorization. And really, all it is the process of breaking down a complicated expression into its original building blocks. Finding the simpler parts that were multiplied together to make it in the first place. Okay, so here's the absolute crucial point. Think of it like this. Factorization is just the reverse of multiplication, right? If you know how to expand brackets and multiply things out, well, factorization is just working backwards. We're starting with the final answer and trying to figure out what the original question was.
All right, so here's how we're going to build your factorization toolkit today. We'll start with the big idea, then get into the common factor, the grouping method, splitting the middle term, and finally, some really cool special pattern shortcuts. Let's dive in.
Okay, first up is the absolute foundation of factorizing. Seriously, this is rule number 1. It's the very first thing you should always check for before you even think about trying anything else. And the idea is really simple. You just look at every single piece of your expression, every term, and find the biggest number and variable that can divide into all of them. That's it. That's your highest common factor, or HCF.
So let's take a look at this example here. We've got 8ab squared plus 12a squared b. So what goes into both? Well, 4 goes into 8 and 12, and they both have at least 1a and 1b. So the HCF is 4ab. You just pull that out front, outside the brackets. Then to figure out what's left inside, you just divide each of the original terms by that 4ab. It's a really simple but super powerful first step.
Okay, that's great and all, but what happens when there isn't one single factor that's common to all the terms? What do you do then? No problem. That's where our next tool comes in, the grouping strategy.
Now this is a really clever little trick, especially for expressions that have 4 terms. What you do is you group them into pairs. You factorize each little pair separately, and then, like magic, a new common factor, a whole bracket, often just appears.
And here is that magic moment in action. So look at this expression, AB plus BC plus AX plus CX. First, we group it into 2 pairs. Then we factorize each one. The first pair gives us B times A plus C, and the second gives us X times A plus C. And there it is. See it? That A plus C bracket is now our new common factor. So we just pull that out to the front. And what's left over? The B plus X. Awesome, right? All right, let's move on to something you are going to see all the time in algebra, the trinomial. That's just a fancy name for any expression with 3 terms. And it usually looks something like ax squared plus bx plus c.
So the key to cracking these is to solve a little puzzle. You're on the hunt for 2 magic numbers. And these numbers have to do 2 things at the exact same time. First, they have to add up to make the middle number, b, and second, they have to multiply to make the product of the first and last numbers, a times c.
Let's see it in action with x squared plus 5x plus 6. So we need 2 numbers that add to 5 and multiply to 6. And, yep, it's 3 and 2. So what we do is we use those numbers to split that middle term. The 5x becomes 3x plus 2x. And just look at that. We've turned our 3-term problem into a 4-term problem, which means we can solve it using the grouping method we just learned. See how it all connects? Okay, you've got the core methods down. Now it's time for some power-ups. Think of these as your factorization shortcuts. If you can train your brain to spot these special patterns, you can solve some of these problems in an absolute flash. And this first one is an absolute classic, the difference of 2 squares. Anytime you see a perfect square minus another perfect square, you don't even have to think about it. You can just slap this formula right on it, and you're done. Oh, this is such a satisfying shortcut. Take a look at x squared minus 25. All you have to do is recognize that, hey, 25 is just 5 squared. The second you spot that pattern, you can instantly write down the answer, x plus 5 times x minus 5. Done. It takes seconds. Now, there's a similar pattern for cubes. It's a little more advanced, maybe a little longer, but it's just as useful. If you see a perfect cube being added or subtracted from another perfect cube, yep, there are special formulas for those too. And this just shows you how powerful this is. I mean, look at a cubed plus 27b cubed. That looks really intimidating, right? But all you have to do is recognize it for what it is. That's a cubed plus 3b cubed. Once you see that, you just apply the formula for the sum of two cubes, and the factors basically just fall into place. It's awesome.
So let's wrap this up. What you should take away from all this is a clear game plan, a checklist for every problem. Step 1, always check for a common factor first. If that doesn't work, try the grouping method. If you've got a trinomial, try splitting the middle term. And all the while, keep an eye out for those amazing shortcuts like the difference of squares.
So there you have it. You've gone from looking at a confusing mess of symbols to having a complete toolkit to break it down into its simplest, most elegant parts. And that, right there, is the real power of factorization. Finding the simple building blocks hidden inside the complex. The only question left is, what are you going to simplify first?